take it slow, but it's not typical. He already knows that my love.
Okay, so we are looking today at graphing functions. We are specifically going to look, I suppose, at the quadratic function. Now, we've met quadratics before this, and we know quadratic is any kind of equation or any kind of an expression that has a square in it. So, say, for instance, the name of this quadratic could be something like x squared plus 2x plus 8, we'll say. And we know, very familiar with this one here, this is our straight line, and it forms into the equation of y equals mx plus c. So if we recall correctly, we remember the m stands for the slope, and the c stands for where it hits the y-axis. So in this case, we might say that, okay, well, this line might hit the y-axis at, say, minus 5. So we could tell that straight away this is going to be y equals mx minus 5. So we will be able to, I suppose, deduce a small amount from looking at the graph. To get the slope then with this one, we would do rise over run and work it out that way. Quadratics, as you can see here, it would be very difficult to find their slope, and the reason for that is at this section here the slope is negative, and then at this section here the slope is positive, which means the slope is changing and it's not just one slope the whole way as it would be in this case. So the slope is difficult to find, but that number on its own, the c, is still present, okay? So if we were to, I suppose, extend on this graph here, and according to this, it should hit the y-axis at 8. So to be aware of that. The other two graphs that we need to be able to recognize are the exponential graphs. And this is one that changes extremely quickly. So say if you have 2 to the power of x, it is to the power, so therefore it's exponential, and the exponential part is the variable here, or the power part is the variable. So you might have 2 to the power 1, which we know is 2, 2 to the power of 2, which is 4, 2 to the power of 3, which is going to be 8. And what you can see here is it's actually getting bigger very quickly. And that's what happens with an exponential. It will be in this shape where it gets quite small and quite big quite quickly, or otherwise it can go small and big, or big and small. Cubic, again, you can spot it here. So a cubic here is up and down, so a variation between your quadratics. Nearly, it's looking like a positive quadratic, which is always in the shape of a U, and then a negative quadratic put together. And you can see here that the cubic, there's no constant slope there either. So that might be an x cubed graph, and you might have some other things added in there as well. So as I said, today we're focusing on the quadratic, but it's important to recognize the exponential and cubic and link our knowledge so far with the line. Okay, I did touch on it there for a few seconds in the last section, but it was about the quadratic graphs. And if it's in the shape of a U, we would immediately say that that's an x squared graph. And if it's in the shape of an n, we would say that that's a minus x squared graph. Now, if I was to have a 2x squared graph, again, it would still be in the shape U, and a minus 2x squared graph would still be in the shape of an n. So important to remember. Okay, so it brings us on to the question that we have today, and it's graphing functions f of x when 3x squared minus 2x minus 7 in the domain of minus 2 is less than or equal to x is less than or equal to 3. We're also told here x is an element of the real numbers, which means it can be any number in between these. We're then asked some questions on the graph. So this all occurs from reading the graph here. And then the last part asks us to use algebra. So before I kind of read through these, we're going to start off with the first part of the question, which asks us to graph the function. Graphing a function here, guys, it's super important to lay it out correctly, and we always do this via a table. So the domain, we spoke about this in class, and again, that is your inputs, and then your range would be your outputs. Your function changes from question to question, and in this function here, I can see that the function is 3x squared minus 2x minus 7, and my inputs, or my domain, it goes from -2 to 3. So laid out correctly, I start at -2, -1, 0, 1, 2, and the last one here is 3. So what I'm going to do is I'm going to place my input in, I get my range out, and then I'm going to have couples. And once I have the couples, I can easily draw them on my graph. So if I place in -2, I'm going to get 3 times -2, all to be squared, -2 times -2, -7. So if I did a little bit of work in my head there, -2 squared is 4. 4 times 3 is 12. So I'm going to have 12 here, plus 4, -7. So 12 plus 4 is 16, -7 is going to be 9. And so my first couple is -2 and 9. My second couple is going to be 3 times -1 to be squared. -2 times -1, -7. So again, -1 squared is 1, so it's going to be 3 plus 2, which is 5, -7, which is going to give me -2. And my second couple here is -1, -2. Then I'm going to move on to the 0. 3 times 0, all to be squared, -2 times 0, -7 will just give me the -7. And I've got 0 and -7 as my next one. Place in 3 times 1. And I'm going to have 3 -2 -7. So -2 and -7 is -9, plus 3 is going to give me -6. And I have 1 and -6 here. And the next one, 3 times 2 squared is 4. 4 2s are 12. 12 minus 4 is going to give me 8. -7 is going to give me 1. Hopefully I've done these right. So 2 and 1 is the next one. And the final one is 3 times 3 to be squared. -2 times 3, -7. So 3 squared is 9. 9 3s are 27. 27 minus 6 is going to give me 21. And 21 minus 7 is going to give me 14. So 3 and 14. And again, I've done these quite quickly. You would obviously take more care in the exam to make sure you don't make any mistakes. Okay, so using my table here, I'm going to fill out my graph. I've put my graph already in. I might bring it down a little bit further. And I've been very careful to ensure that everything on the y-axis, it's the same space between each one. And, you know, something that people may not be aware of is you can actually change the space for the x-axis. It doesn't need to be one box just because your y-axis is. It does, however, need to be the same the whole way through. So because obviously there's nearly 21 units on the y-axis that we need to have in, and we only have 6 on this axis, it would be very squished if we just concentrated it on these 6 boxes. So I've just stretched it out. All right, so let's start plotting. So the very first one is -2 and 9. So I go along as far as -2, up as far as 9, and hopefully you're with me and you're imagining the same dot as where I'm placing them. Next one is -1, -2, along as far as -1, down as far as -2. Along as far as 0, down as far as -7. Along as far as 1, down as far as -6. Along as far as 2, up as far as 1. And along as far as 3, up as far as 14. Okay, so if I connect all of those, and I'm going to use a black pen to do that, or a black marker. You do this freehand, you never do this with a ruler. We can see that it is indeed part of the x squared group. It's in the shape of a U, which is correct. Now it was 3x squared minus 2x minus 7 was my graph that I had to draw, and I know that this number on its own is called C, and it's where it hits the y-axis. And yes, if we actually have a look, it hits the y-axis at -7, so it's just another test that we've done it correctly. Again, if you're not getting a nice U shape here, you need to go back and fix it, okay? It's a clear sign that you've gone wrong somewhere. Okay, so now I have my graph, and I've got all of these questions that I was asked, and the questions did say estimate from your graph, which means you need to use the graph you've just drawn. So it says find the value of f of 2.5. So remember, this is the graph f of x. This is the function f of x that you've just created. So they're asking, okay, well, f of 2.5. And what they're asking for is, along the x-axis, where does 2.5 hit the graph? So if I'm to zoom in here, and I'm going to go along as far as 2.5, which would be around here, I then go straight up until I hit the graph and over. Okay, so I'm saying roughly here that the answer to 2.5, the f of 2.5 from my graph, from estimating, would be around 4. Or maybe even 4.5, would we say? Yeah, okay. The next part of that question. Find the values for x for which f of x is equal to 3. So this is f of x. This is my function. Where is this equal to 3? So it is equal to 3. Let's find out. So what I'm going to do is I'm going to get a nice straight line, and I'm going to make sure I pick the line button. Yeah, 1 second. Okay, and I'm going to place that line button, and maybe might do this one in green, all along 3. Okay? What I've drawn there is that is the line where y equals 3. And if that's the case, where does this function hit it? So I'm going to zoom in, and I should be able to get some answers here. So the very first one, it hits it at this point here, and it hits it at this point here. So you might say it hits it at, say, 2.4 maybe, and along here it's probably minus 1.5. Okay, so they are the two answers for that part there. Again, we're just estimating, so everyone's graph will be a tiny bit different. So you do have a little bit of leeway by the examiner in this case. It's more about having the correct method. The next one, it says, find the minimum value for which f of x, remember this is f of x, this curve I've just drawn, and the value of and the x value at which it occurs. The minimum value of f of x and the x value at which it occurs. Where is the f of x minimum? Where is the f of x at its minimum? You can see here I'm going to use a line to show you, and I might even get that line to be, well, I might go with a yellow line this time. You can see here that this, judging by my diagram, is the lowest point of the f of x, and in that case, what is the x value? So what would that point be there? So the point is, we're saying it's going to be along as far as maybe 0.5, and then it might down as far as maybe -8 or -9. That's the point. This is my x value, this is my y value, and the question asks for your x value, so the answer is 0.5. And then the very last question it asks, using your graph, find the range of values for which x is, this symbol here, greater than or equal to 0. So where is this graph, the function, they didn't call it there, they call it the actual name, 3x squared minus 2x minus 7. Where is this function greater than 0? So at this point, the function is less than 0, less than 0, less than, hang on now till I just get my thing again. Yeah, less than. Here we've got, one part of it is positive, but one part is still negative. So the only point where the whole lot of it is positive is actually from about this point here until about this point here. So if I was to just circle it, at that point there, that's when the graph is completely positive. And so it is the value for x, or the function of x, is positive when it is less than or equal to, I'm going to say that's around 3.4 or maybe even 3.5, and bigger than 1.9. Okay, so that would be the correct answer for that. Remember, at this stage, some of the values are positive, so the x value is negative though. Okay, find the range of the values for x. So you're just constantly looking at the x, and it only starts to be positive from this section here. Okay, the last part of that question asked me to solve it algebraically, and I'm going to leave you guys to do that one yourselves. Nice and easy, you're finding f of 2, and then you're finding when f of x is equal to 3. So nice and easy to finish off. Ensure you have all your notes taken down from this lesson, and I'll see everybody tomorrow.